Hi, I'm Alex. I'm the inventor of Volumetric Solar Architecture. Volumetric Solar is a 3D parallel architecture for bifacial solar panels. Today, almost every single panel is wired in series, and that limits the amount of energy that they can generate. Volumetric Solar Architecture enables bifacial panels to be wired in parallel, and that lets them collect more energy with both direct sunlight and a reflection boost, allowing more energy within less land area. So panels wired in series today, both monofacial and bifacial panels, are limited to the amount of current that can be collected, and they can only collect this current during the peak times of the day. Volumetric solar architecture is wired in parallel, so it can collect current from the inside surfaces and the outside surfaces from sunrise to sunset, making them more efficient over longer periods of time. In addition to direct sunlight, volumetric solar can also efficiently capture reflected light, which can't be captured today by panels wired in series. So reflected light can be light that bounces off the snow in the winter, or it can be reflective surfaces in any season, and that reflected light turns into more amps. So to understand how much better volumetric solar is, we need to understand that every solar panel generates DC power. And when solar panels are connected in series, they have their voltages added together, and the current is the minimum current of whichever panel is the lowest. So when we have shading losses, that is because solar panels are wired in series. With volumetric solar architecture wired in parallel, we can eliminate a lot of those shading losses by adding all of the currents together. And our DC power is always our voltage times our current. So we want to maximize our current first. And so with series wired panels minimizing the current, you're losing that energy automatically as the first step. With volumetric solar wired in parallel, we're collecting the power from every bifacial panel, the front side, the back side, and we're collecting both the direct and reflected light together. And that lets us boost our current. And the amount of energy per day is the DC power multiplied by the time. So our maximum energy is going to be the maximum current multiplied by the maximum voltage across the maximum time of the day, which is sunrise and sunset. So to do this, the critical difference is we have to add the currents first in parallel and then add the voltages together by connecting the units in series once we have a current that's high. And so this architecture allows us to create customized circuits that have a combination of high current and high voltage for the most possible energy. And so this vertical architecture can be extended upwards. It can also be used for charging batteries and can also be used in existing solar string inverters. And that lets us create new microgrids that are vertical, that can automatically shed snow, that can collect both direct and reflected light, and can ultimately provide more power and then more energy per day for battery charging and for turning into AC power as well. This is a video on volumetric solar 3D parallel architecture. You can get more information from our website, volumetric.solar.